Now that we're getting to the coding part, I need to stress to absolutely use the GitHub repository or web3dev.education associated with this course. If you're on the GitHub repo right now and you scroll down to lesson 2, and this is going to look a little bit different when you come to it, you can click on the GitHub repo associated with this lesson. This will have all the code that we're actually going to be working with for this section, as well as a README section, which is going to have a lot of notes on how to actually work with the code. And instead of making issues and discussions on this repository here, if you have an issue, please use the discussions tab of the Foundry full course here, or use any of the areas that we've laid out in the questions section. We're going to teach you how to ask questions so that they have the highest probability of being answered by either somebody else in the community, by an AI, or by a forum. Additionally, please be sure to check out web3dev.education for more information as well. I highly recommend that you pause the video right now and make accounts for, first of all, GitHub, and then at least Stack Exchange Ethereum. Additionally, ChatGPT is a great resource to make an account for. Just remember that it will often get things wrong and isn't quite up to date. Find you don't need to make an account for, but it often gets things wrong sometimes as well. Typically for each coding section, I'll give you a brief rundown of what we're actually going to be building. And in this lesson, we're going to be building this exact smart contract, and we're going to be building your first smart contract ever, and we're going to deploy it to a blockchain. At the end of this section, you are going to have deployed your first smart contract ever. So be sure to get to the end so you can deploy your first smart contract. We're going to be using something called an IDE called Remix to deploy and interact and work with this smart contract, which is going to be very exciting. It's highly recommended to get the best experience out of this is for you to follow along and you to code with me. You can change my speed on the YouTube video if I'm coding too fast or I'm coding too slow. But you taking the time to write out the code as I code along with you is going to ingrain the knowledge into your brain. Repetition is the mother of skill, and I want to make sure you come out the other side with skill. To actually code this, we're going to be using a tool called Remix. You can either Google search it, or you can just come to the GitHub repo or web3dev.education and click this link to Remix, which will pop open the Remix Web IDE. So let's go ahead, let's jump in, and let's learn to deploy our first smart contract. At the end of this lesson, you will have deployed your first smart contract. You'll have written your first bit of Solidity, and we are very excited to get through this part. Welcome to the Remix IDE, or the Integrated Development Environment. This is where we're going to learn to write a lot of our code in the beginning. If you want, you can go ahead and accept to help out Remix here. And if you've never been to the Remix website before, it'll give you a tutorial walkthrough of some of the features that Remix has to offer. For example, it has a Solidity compiler. Solidity is the programming language that we're going to be using in this course to code our smart contracts. And we need to compile them when we've written the Solidity. We'll learn about that in a little bit. We have a tab here where we can actually deploy our contracts to a blockchain. And we have all these different folders and scripts, since we can actually write JavaScript and TypeScript in Remix as well. But don't worry about those too much for now, because I'm going to be explaining everything that we're going to do. Remix is an incredibly powerful tool because it has a lot of features that will allow us to really see and visualize what our smart contracts do. Eventually, we're going to move off of Remix to a local development environment. However, Remix is a tool still used by some of the top auditors and smart contract developers in the space when they want to quickly check something out. And additionally, it's fantastic for learning the fundamentals of Solidity. The left-hand side is where we're actually going to start interacting with Remix. If we bring our mouse up to the top, this little file explorer is where we're going to have all of our files and where we're going to write our Solidity or our smart contract code. If you want, you can leave all these folders in here, but I'm actually going to go ahead and delete everything so that there's less for me to work with or deal with. So I'm just going to go ahead and right-click and delete everything in here, just so I can start completely from scratch. Again, if you want to leave all of these in here, feel free to do so. Doesn't matter. I just think it's cluttering up my mental space a little bit. Now we have a blank Remix project. And the first thing that we're going to want to do is create our first file to start writing and deploying our Solidity smart contract. We're going to go ahead and click the Create New File right here and type in simple storage.sol. .sol tells our compiler that this is going to be a Solidity contract, a Solidity file, and we're going to be writing Solidity inside of this file. which again, Solidity is the most popular smart contract programming language. And you'll see we actually get popped up a simple storage.sol on the right-hand side, which we can type in and actually write our Solidity code. Now, right below the File Explorer button is a little search icon, which allows us to search for different code in all of our contracts. So for example, if I type in hello in here and I copy that, paste that into the search bar, hit enter, we can see that it found this line hello in our simple storage.sol. Let's go ahead and delete that. Right below that search icon is this Solidity compiler. And you'll see a bunch of different stuff pop up, which tells us about our compiler configuration. And we can see even more advanced configuration if we hit the dropdown. We're not going to hit that for now. Let's go ahead and double click the Solidity compiler over here so we can just see the simple storage.sol. I'm also going to click this hide terminal button so that we just see our simple storage.sol. Now, the first thing that we want to do in all of our Solidity and smart contracts is write the Solidity version that we're going to be working with. Solidity is a constantly changing language, and we want to be very specific about what version we're going to be using to write our smart contract, as each version does different things. To write your version, you're going to do pragma, Solidity, and then type your version. For most of this course, we're going to be using 0.8.19, as that's the most current edition of Solidity. However, getting used to working with different versions of Solidity is really good for you, as you're going to be working with different versions of Solidity no matter where you go. Certain versions of Solidity are considered more stable than other versions. Right now, there's a popular tool called Slither, which recommends using 0.8.18. So if you want to default to 0.8.18 for this course, feel free to do so. We're going to be using a couple different versions as we code. So this line says we're stating our version. Now, these two slashes here stand for what's called a comment in Solidity. And this allows you to write anything after the two slashes. And when we compile or run our code, it will just ignore what's in here. So we could type blah, 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 whatever we want. Cats are cool. And it doesn't matter. You can write anything in here. I highly recommend, as we're going along, you should write comments in your own code as well for you to refer to later on. And additionally, feel free to copy all the code that you write and paste it locally so that just in case your browser cache refreshes or something, you won't lose all the work you've done. So before you log off for the day, copy paste this into a text file so that you can have it for later. But a good comment for here might be, this is the version. Now, writing our version like this in Solidity tells the Solidity compiler that we're only allowed to use 0.8.18 when compiling this. However, maybe a new version comes out and we're okay to use anything newer than this version. To tell the compiler that, we add this little hat, this little caret, which says this contract only works with 0.8.18 or anything greater than that. This means 0.8.19 would work. When 0.8.20 comes out, that one would work. However, 0.8.17 would not work if we were working with 0.8.18 or above. If we don't have the caret, this tells the compiler that only 0.8.18 will work with this code. If we want to use Solidity versions within a range, we could do something like this. We could say we want our version to be greater than or equal to 0.8.18, but less than 0.9.0. This would tell the compiler that any version between these two is a valid version. For example, 0.9.1 would not work. Neither would 0.9.0, because these are not strictly less than 0.9.0. Great, so now we know how to do compiler versions. Now, the next thing every smart contract needs to start with is something called the SPDX license identifier. Now, this actually isn't required by the compiler. It'll actually throw a warning if we compile and it won't error. It's fine if you don't have this. However, it's highly recommended. This is a way to make licensing and sharing code and IP of your contracts a lot easier from a legal perspective. I have a link to more about how licenses work in the GitHub repo associated with this section of the course. MIT is known as one of the most permissive licenses. It basically means anybody can use this code and pretty much do whatever they want with it. I wouldn't worry too much about the licenses right now. But let's actually go back to 0.8.19. And on the left-hand side, let's scroll down to this compiler button and open this back up. Even right now that we don't even have any code, we can actually go ahead and compile this contract. Now you might see a red squiggly and you might see a warning here, but don't worry about that for now. To choose our compiler version, we scroll up to this section and we can choose the compiler version that we want to work with. Most of the time though, if you just hit compile simplestorage.sol or you hit this big compile button, it'll automatically choose the version for you. For example, if I scroll down, but I hit compile, it'll automatically flip up to 0.8.19. And we were able to successfully compile this code. Now, it says no contract compiled yet because we haven't put a contract in here yet. We just put the version of Solidity that we're working with. Compiling our code means taking our human readable code and transforming it into computer readable code, which is essentially a bunch of zeros and ones, or it's byte code. Computer code is very specific instructions for the computer to use, or in our case, the blockchain to use for our contract. We'll learn later about machine level code and opcodes and EVM codes in a much later section of this course. Additionally, you can hit Command S or Control S, which will also save and compile. You'll see I kind of have a trigger finger and I will, out of habit, hit Command S all the time. Because as somebody who codes a lot, I need to make sure I save all the time, otherwise things might not work as intended. As you saw, if we use a different version of Solidity and we hit the compile button, it'll automatically flip back. But for example, let's say I wanted to use 0.8.7, anything greater than that, and we're on compiler 0.8.19, and we hit compile, it won't change. However, if I use something less than 0.8.7 and we hit compile, it'll change because it wants to automatically select a Solidity version that is appropriate for the version that you chose. Again, I want to use 0.8.18, and I'm going to hit compile, and we're good to go. Now we're going to go ahead and start writing our contract. And to get the full screen view again, we just go ahead and click the Solidity compiler so that we can just see our code here. To start writing our contract, we're going to use a keyword in Solidity called contract. This tells Solidity that the next piece of code is going to be the name for our contract that we're going to create. You can think of a contract very similar to a class if you're familiar with JavaScript or Python or Java or really any object-oriented programming. And we're going to go ahead and give our contract a name here. We're going to call ours simple storage. And then we add this little open and closed curly braces or curly brackets. Everything inside of these curly brackets is going to be considered part of this contract simple storage. Now, if we hit enter, we go back to the compiler and hit compile, we can see once again this little green check mark pop up. This means our compilation has been successful. If we were to remove, for example, this curly brace and hit compile, we would get this error. Compilation failed with one error. And if we scroll to the bottom, it'll tell us where the error actually is. And we'll get a little red pop-up saying what line the error is actually on. We'll learn about debugging these errors in a little bit, but let's add the curly brace back. Go ahead back to the compiler, hit compile, and we're good to go. Hypothetically, we could deploy this smart contract right now. This is a valid contract, although it doesn't do anything. But congratulations, technically, with just this little piece of code, you've written your first smart contract. I spelled version wrong, so we're going to correct that. Solidity has many different types of things that you can build in these smart contracts. Many different data types or just types. If you go to the Solidity documentation at docs.soliditylang.org, again, link to this in the GitHub, we can select the types section on the left-hand side to learn more about Solidity types. If you want to get a holistic view of all the different types, you can go ahead and read this documentation. Some of the basic types are going to be Boolean, uint, and an address, and bytes. Bytes is a lower level type, which we'll talk about in a little bit. A Boolean is some type of true-false value. A uint is going to be an unsigned integer, aka a positive whole number, meaning no decimals, no fractions. A integer is going to be a signed whole number, meaning it could be positive or negative, but again, is a whole number. And then we have an address, which is going to be, well, an address. It's very similar to if we open up our MetaMask and we click this account here, it's going to be something like this. There are some other types as well and ways to create your own custom types, but we'll learn more about that later on. We can use these different types to define different variables. Variables are essentially holders for different values, and these values can have one of these types. For example, we could create a variable called hasFavorite number, which would represent if somebody has a favorite number. This hasFavorite number could be true or false. Either they do have a favorite number or they don't. To tell Solidity that this hasFavorite number is a true false or a Boolean, we would add this bool keyword before has favorite number. So this has favorite number is going to be either true or false. And to set its value, we're going to give it this little equal sign and say true. So now has favorite number is a variable that represents true. We could also say has favorite number is false, meaning that somebody doesn't have a favorite number. For a uint, which again is an unsigned integer, we could say uint favorite number equals 88. This means that this variable, favorite number, is going to be 88. A uint and int are actually special in that we can actually specify how many bits or bytes that we want to use. For example, we could say uint 256. Uint 256 specifies this variable favorite number has 256 bits. We're not going to go over bits and bytes in depth right now, but if you want to get a quick refresher, we've left a link in the GitHub repo associated with this course to give you an overview of bits versus bytes and how they work. An easier way to think about this is really just how big can it get? The bigger the number over here, the bigger this favorite number can be. The maximum size is a uint 256. And if you don't specify the uint 256, it defaults to being a uint 256. So this and this are the same thing. This, same thing. You could also have 8 bits, 16 bits, 64 bits, etc. Oftentimes, it's better when we're writing our code for a readability standpoint to be as explicit as possible. So you'll see me pretty much always writing uint 256 because I want to be very explicit with how many bits I'm using for uint 256, even though they mean the same thing. Instead of a uint 256, we could also have this be an int 256. And actually, let's add that Boolean back up here. Now, an int can actually be positive or negative. So we could have our favorite number be negative 88 if we wanted to. We can also have strings or text variables, which I didn't name up here, but I'll say why in just a minute. We could say string favorite number in text equals 88. And let's actually make this positive 88, even though an int could be positive or negative. I'll put this little semicolon here. You'll notice that at the end of every one of these lines, I'm adding this semicolon. This semicolon is how you can tell Solidity that a statement has completed. So this semicolon is saying the end of this line is right here. If we wanted to, we could put all of our code on the same line like this, and this would compile fine. It just looks really ugly. So we always want to put our code on a new line after the semicolon. A string in Solidity is basically text that represents, well, words. So I could say 88 instead of having 88 in here. To tell Solidity that something is a string, you have to put it in between quotes. I could put really any combination of characters in here, even like hello or follow Patrick on Twitter. And let's actually do uint 256 here, favorite number, and we'll do an int 256 favorite int equals negative 88. This way we'll just have an example of all these different types on screen. We can also do an address. So we can say address, my address equals, and we can go into our MetaMask, copy the address and paste it right into Remix and add that semicolon. And now we have our address type in Remix. And then finally down here, we're going to say a bytes32 object, favorite bytes32 equals cat. And we're going to put it in quotes, just like we did the string up here. And what's interesting about the string object is that strings are actually secretly just bytes objects specifically for text. So a string can actually get converted to a bytes object really easily because under the hood, they're essentially the same thing. Bytes typically look like something like 0x and then a whole bunch of random numbers and letters that represent the hex of whatever the bytes is and can often be represented as strings like cat. We'll talk about bytes more in the future. Similar to uint 256 and int 256, you can have different size bytes, like bytes 2, bytes 4, bytes 8, etc., all the way up to 32. You can also have just straight up bytes and not have a number after, but that's a slightly different type, and we'll go over that later as well. A uint like this and a uint 256 are the same thing, but a bytes 32 and a bytes with nothing are actually different. So keep that in mind for now. The largest bytes, like I was saying, is actually 32. So for example, we can't do a bytes 64. And if we type that in here, Remix actually goes, hey, there's an issue here. And if we try to compile this, and we scroll down, we'll again see this little error code here and this little error pop up. It even gives us an output declaration error, identifier not found or not unique. It gives us the line and we can say, whoops-a-daisy, this should be a bytes 32. And we can go back and compile this. For our simple storage contract, let's say that we only want to store a favorite number. This contract is going to be a contract that allows us to store our favorite number and some different people's favorite numbers as well. So we're going to go ahead and delete everything except for the uint256 favorite number. So we're going to go ahead and delete everything and boom. And we'll pick a smaller favorite number just to make it a little mentally easier. Now, these variables actually have default values. So for example, if I don't set my favorite number to anything and I have a line that looks like this, you'll see that this actually compiles fine. Favorite number will actually get defaulted to 0, and all of these types have a different default value. uint256 is 0, booleans is false, etc. So saying uint256 favorite number and not having an equal sign after here is the same as doing uint256 favorite number equals 0. So for now, let's not initialize it to anything so that favorite number starts off as 0. And remember, as you're coding along here and typing along with me, if you get confused, make sure to write your own comments. For example, we can say favorite number gets initialized to 0 if no value is given. Now let's go ahead and learn to make our first function. Basic Solidity Functions section. Functions or methods are a subsection of code that, when called, will execute a very specific small piece of our entire code base. If you're familiar with JavaScript or Python or any other programming language, functions in Solidity are exactly the same. Functions are identified by the keyword function. Let's create a function and name it store. And we're going to have this function be responsible for actually updating our favorite number. We're going to store a new favorite number. So you first write the function keyword, the name of the function, and then you add these two parentheses. Whatever is in between these two parentheses represents what we're going to pass or send to our function, or the parameters that we're going to send to our function. For example, we need to tell our store function what value it should use to update favorite number. So we're going to tell our store function it should take a uint256, and this variable that we're going to pass to it, we're going to call underscore favorite number. It's important that we give it a different name than favorite number up here, and we'll talk about that in a little bit. Then we're going to say this is going to be a public function, and we'll explain that soon too. We want to put these little curly brackets in here as well, and we're just going to say favorite number equals underscore favorite number. And without going too deep into what this is doing, we're saying, I'm not going to explain public yet, but we will in a minute. But what we're saying is whenever you call this store function, you're going to set our favorite number variable to whatever variable that we passed. I'll explain why we do this underscore here as well in a little bit. And with just this, we can actually start to simulate what this smart contract will do and if our store function will actually work correctly. So what we can do with just this code right here is come over back to the compile tab and hit compile, make sure that we get this green check mark and that everything looks good. And then we can go down to this deploy and run transactions tab. Our deploy and run transactions tab has a ton of different parameters in here on how to actually deploy and run with our transactions. We're going to deploy this contract to a simulated virtual environment. So we're going to deploy it basically to a fake environment. We're not going to be deploying it to a testnet. We're going to deploy it basically in kind of an imaginary world. In order for us to do this, first, make sure we're on this Remix VM. And for us, we're going to just use the default, which is the merge. Doesn't really matter which one you're on, just so long as it's the Remix VM. This Remix VM is a fake local blockchain where we don't have to wait for transactions to complete, and we don't have to deal with any of the oddities on deploying our code to a real testnet or a real mainnet. And don't worry about the rest of these for now. We also get an account here. When we run on our fake Remix VM, we get automatically given an account with a different amount of Ethereum for each account. You can think of each one of these accounts similar to our MetaMask accounts in MetaMask, except for these are fake imaginary accounts that Remix just gives to us. For our transactions, including deploying contracts, we're given a gas limit, values that we can send, and we'd also choose our contract depending on which one we've compiled. Since we only have one contract in here, we only have one to choose from. So on the left-hand side, to deploy our contract to this fake Remix VM environment, we're going to go ahead and click the deploy button. If we scroll all the way down to the bottom now, under this deployed contracts, we can see we actually deployed a contract here, simple storage. We can see the balance is 0, and we see this big orange button that says store, and then uint56 underscore favorite number. On our local blockchain, this at blah, blah, blah here, this is going to be the address of our contract. Similar to our wallets, how they have different addresses, every single contract has a unique address as well. And if we hit this little copy button and we close this and we put it as a comment here and we paste it, we can see this looks exactly similar to an address such as what's in our MetaMask. And then let's go ahead and open the deploy back up and we see that deployed contract is still there. Additionally, if you hit this little show terminal button and you pull this up, we can actually see we have this little comment here, creation of simple storage pending, and we have this green check mark here. This is notating that we actually sent a transaction to deploy this contract. Similar to sending ETH back and forth, in order for us to deploy a contract, we actually have to send a transaction. Since we're doing this on the Remix M, this is a simulated transaction, a pretend transaction inside of our Remix environment. You can even hit the little drop down and see even more information about this transaction. You'll see a lot of familiar keywords like status, transaction hash, from, to, gas, etc. Deploying a contract uses the exact same process as sending a transaction for just ETH. The main difference is we populate this data or input field with a ton of that bytecode. And if you copy this input field or this data field and go ahead and make a comment in here, you'll see it's a massive line. And this massive line notates all the data associated with this smart contract, all the machine readable code. Remember, anytime we do anything that modifies any value on the blockchain, we actually do that by sending a transaction. Deploying a contract is modifying the blockchain, so we do it in a transaction, which means, yes, we spend gas. Now, this big orange button over here actually resembles our function store in our smart contract. And if we add some numbers in here and we call it, again, if we pull the terminal up, we can see transact to simple storage pending, and we see we sent a transaction which called this store. If we do this again with a different number, we call it, we can see our terminal say, oh, you sent another transaction to update the state of the blockchain. And if we scroll all the way up to our account, you'll see that we have a little less Ether in our account because we had to spend the gas associated with, well, A, deploying this contract, and then B, calling these functions. And then, for example, if I add 5 in here and hit store, we'll send a transaction to store 5 on the blockchain. Now you might be thinking, okay, Patrick, that's pretty cool, but what is the value of favorite number? You're telling me that this function store is updating favorite number, but I can't really see it. How do I know that favorite number has actually been updated to 5? Well, the reason we can't see it is that the visibility of our favorite number is actually defaulted to internal. So us not having anything here or writing internal are actually meaning the same thing. And we'll talk about visibility and default visibilities in a minute. But in order for us to actually see the value of our favorite number, we'll go ahead and add the public keyword to this. This changes the visibility of favorite number to public. And like I said, we'll talk about visibility in a minute. But let's go ahead and compile this. Let's go ahead and delete this contract by hitting this X here. And let's redeploy this contract with this new public keyword. So let's go ahead and hit deploy. And now if we scroll down and we open up our simple storage, we actually now see a blue button labeled favorite number. And if we click it now, we can see it returns 0, which makes sense because we know that uint256 is default to 0. Now, if I go ahead and add 5 into here and hit the store button, if I pull up the terminal, we'll see that we went ahead and executed that store function call, that transaction that's going to take input this 5 as favorite number and set it to our favorite number. Now, if I hit favorite number, you can see it does indeed return 5, showing that we actually updated our favorite number with this function call. And remember though, I'm going to go ahead and do this again. And remember, when I hit X here, this is just removing it from this window here. If you actually deploy a smart contract to the blockchain, hitting X from this window doesn't do anything because once you deploy your contract, it's immutable, it's out there, and you can't just delete it by clicking X and Remix. Functions and variables can have one of 4 different visibility specifiers in Solidity: public, private, external, and internal. If you don't give one of these keywords to your variables, it'll get defaulted to internal. Public functions mean that they're visible externally and internally. And you'll see here it says it creates a getter function for storage/state variables. This means that other people can call this function or call this variable. When we didn't have a visibility for favorite number, it defaulted to internal, which is why we didn't see this blue number pop up, because internal. It means that other contracts and people aren't allowed to call on this favorite number. we have a little bit more here. It says it actually creates a getter function for storage/state variables. When we add this public keyword here, it's actually equivalent to us making a getter for this favorite number variable, a getter function. And I'll show you exactly what that function will look like in a little bit. Now, keep in mind though, everything on chain is technically public. So setting a function or variable to private isn't a good way to hide what the value actually is there. And we'll talk a little bit more about storage and visibility and that much later. Just remember, everything on these EVM chains is actually public data. This public variable just means any other contract can call this favorite number and see the value what's in favorite number. And private means only the current contract can. External functions mean they're only visible externally. And this is only for functions, not for variables. And it means another function inside this contract couldn't call an external function. And internal means only the current contract and its child contracts can call the function. We'll talk about child contracts and inheritance in a later section. So let's just keep it public for now. The reason that we have this underscore here in this parameter is because we need to tell users that this variable in here is different than favorite number. And there's a couple different conventions on naming local variables versus these what's known as state variables or variables outside of functions. And we'll go over those later in the course. Now, here's something that's really interesting as well. Remember how I told you earlier that sending Ether is a relatively simple transaction, right? Well, let's see what happens when we call this store function and we update favorite number to 5. Let's actually call it one more time. And we hit the little drop down here. Let's go to gas and we'll see gas actually cost 27,000 gas, which is a lot more than the 21,000 gas it costs to just send Ether between accounts. Remember, every time you update the state of the blockchain, it's going to cost gas. Now, what do you think will happen if we do more inside of this store function? For example, we say favorite number equals itself plus 1. Let's go ahead and compile this. Let's delete our old simple storage. Let's deploy this new one. Remember, the last one cost 27 gas. Let's pull up the terminal. And Remix actually gives us a little tooltip. And it's saying an infinite gas, which we know is actually wrong. But let's go ahead and add 1, 2, 3 in here, and we'll hit store. We'll see this transaction. We'll scroll down. We'll see gas is actually a lot more. It's way more gas. It's 50,000 gas with just adding this line here. Now, technically, I'm not telling the full story here because there are some other gas costs associated with the first time you run a function, but it's still more, right? And that's what's important here. So let's go ahead and delete that line and go back to our old function here. Now let's talk about something called scope for a second. So if I create a variable in here called uint256 test var equals 5, and I create a new function called something, we'll make it public. Could I access the test var and then maybe change it to 6 or 7? What about the favorite number var? What about the favorite number variable? Could I access that to 7? Well, let's go ahead and see what happens if we try to compile this. If we try to compile, we actually go ahead and get an error in our compilation, undeclared identifier. Whenever you create a variable, it can only be viewed in the scope of where it is. If that's confusing, just look for the curly brackets. The reason that our something function can read the test var is because this test var isn't inside of the curly brackets of something. The reason it can't read the test var is because test var was created way up here inside of these curly brackets outside of something. But favorite number wasn't created inside of these curly brackets, so how come it knows what favorite number is? Well, something is inside of these curly brackets, and favorite number was created inside of all of these curly brackets. If favorite number was created inside of here, it wouldn't be able to access favorite number because, again, favorite number is inside of this scope and not this scope. If you create a variable like test var inside of store, you can only access this test var inside of this store function and not anywhere else. The easy way to know what the scope of a variable is just look for the curly brackets. So let's go ahead and delete this something variable, and let's delete this test var, and let's recompile. Now, like we were saying earlier, when we add this public keyword to favorite number, it's the exact same as if we created a getter function to return this favorite number. So let's actually write a function similar to what this public keyword is creating. So we're going to say function retrieve. We'll make this a public view function, and we'll talk about that in just a second. And we'll say it returns a uint256, and we'll add the curly braces here. And we'll say return favorite number. And oftentimes when these auto suggestions come up like this, you can just hit enter and they will automatically do it. So if we do favorite and then I just hit enter, boom, automatically like that. Now I'm going to hit Command S, which is equivalent to me going to the compile tab and hitting compile. Now, if I go to the deploy tab, and let's deploy this contract now, when we scroll down, we now see we still have that store function, we have our favorite number function, and we have a new blue button called retrieve. Right now, they both start off as 0. And then obviously, if we update this to 5 by calling store, yep, I called store, these now both return 5, since favorite number is the actual variable, and retrieve is just returning whatever favorite number is. Now, as you can see here, these two functions are blue, but this one is orange. What's the difference? Why are the colors different? Well, the key is actually with this view keyword here. Solidity has a special keyword which notates functions that don't actually have to run or you don't actually have to send a transaction for you to call them. And those two keywords are going to be view and pure. A function marked view means we're just going to read state from the blockchain. For example, in our retrieve function, we're just going to read what the favorite number variable is. Our store function isn't reading, it's updating something. And it's changing the state of the blockchain. So we have to send a transaction. Since our retrieve function doesn't have anything inside here that updates anything, it just returns favorite number. We don't need to send a transaction. So if you add this view function in here, it disallows any modification of state. For example, I couldn't add favorite number equals favorite number plus 1. If we go ahead and try to compile this, we'll get an error. Function cannot be declared as view because this expression potentially modifies state. So we'd have to remove this line, or we'd have to remove the view keyword. So view functions disallow updating state. Pure functions disallow updating state, and they disallow even reading from state or storage. This favorite number here is what's known as a storage variable because it's stored in a place called storage. We'll talk about that in a later section. But if this was labeled pure, we'd see we get a little red underscore here because favorite number is reading from state. Instead of returning favorite number, we would return something like 7. So this would be an example of a pure function. This would be an example of a view function because we're reading from state. Again, we'll explain the difference a little bit later. And like I was saying before, if we call a view or a pure function, we actually don't need to spend gas since we're not modifying the state. That's why these buttons over here are blue. They're representing view or pure functions, functions that we can call without having to send a transaction. For example, if I pull up the terminal here, and I pull this up, and I call retrieve, we do get another function, but it's just a call, and it looks different than if I hit the store, which has this little check mark. They're different because the store is obviously sending a transaction, and the retrieve is actually just making a call and not sending a transaction. However, something weird is going on here. If I hit retrieve and I go into the details of this call, I can see, oh, what's this? Why is there an execution cost? It says cost only applies when called by a contract. What's going on there? The reason for that is because if another function that does update state, that does require a transaction, calls retrieve, that transaction does need to pay the gas of reading and calling this retrieve function. So calling a view or pure function actually does cost gas only when a gas cost transaction is calling it. So we can go ahead and call these as much as we want. It costs nothing. But if another function that does cost gas calls it, it's going to cost something. For example, if our function store here then went ahead and called retrieve like this, since store costs gas, you're telling this function, hey, also call this retrieve function, which is more work for it to do. And since it's more work, it's going to cost more gas. So for example, if we delete this contract over here, let's go ahead and compile this. Let's go ahead and deploy this with this retrieve in here. So let's go ahead and look at these. These are now 0. We'll store 5 in here. We'll select the dropdown. We can see how much gas we actually sent, 50,000 gas. Let's go ahead and drop this now, close this out. Let's remove the retrieve line. Let's compile, we'll hit deploy, simple storage. These are both 0. We'll add 5, hit store, pull up the terminal, hit the dropdown, look at gas. It's still 50,000, but it's actually a little bit less than before. Although I'm pointing at gas, we really should be looking at transaction cost because gas is really just actually how much we're sending, whereas transaction cost is how much gas the transaction actually cost. But in any case, it was a little bit less without the retrieve function. Now, I've kind of been glossing over this a little bit, but this returns keyword specifies what this function is going to give us when we call it. So when we have this returns keyword in our retrieve function here, we're saying whenever we call this retrieve function, we want to get returned, or we want to be given this favorite number of type uint256. We want to return a uint256 from this function. Now, our contract as is pretty good. It does one thing pretty well. It allows us to store our favorite number, update that favorite number, and then view that favorite number. And in fact, let's go ahead and make this an internal variable, and we'll have the retrieve function be the way to get this. We can have this public, but for now, we're going to set it up like this, and I'll tell you why we're going to set it up like that in the future. But what if we wanted to be able to store not just our favorite number, but other people's favorite numbers as well? Well, what we could do is we could create something called an array, or a list of favorite numbers. What we could do is we could say, instead of just one uint256, we could have a list of uint256 called list of favorite numbers. This bracket syntax here identifies that we have a list of uint256, or a list of numbers, or an array of numbers. An array of numbers is going to look something like this. It's going to have, maybe the first element is going to be 0, maybe the second favorite number is going to be 78, maybe the third favorite number is going to be 90. Now, arrays are very common in computer science and programming, and an array in Solidity is exactly the same as an array in any other programming language. If you're unfamiliar with arrays or lists are actually 0 indexed. So the 0 here is actually at index 0. So we refer to this object here as the 0th object, right? This could be 77, and this would be the 0th object. The 78 is going to be the first element, the 90 is going to be the second element, and so on and so forth. It's very common in computer science to actually start counting from the number 0, and arrays start counting from the number 0. We'll learn to play around with arrays more in just a minute. So this list of favorite numbers is great, but how do we know whose favorite number each section is? If this is our list of favorite numbers, how do we know who 0 is, who 78 is, who 90 is, etc.? Well, maybe what we would do, instead of just having a raw list like this, let's go ahead and comment this line out, maybe we could create a new type called a person. In Solidity, you can actually create your own types using the struct keyword. So we're going to say struct person and do little curly brackets like this. Inside of these curly brackets, we can define what this struct person custom type is comprised of. And we're going to say for every person, they're going to have a uint256 favorite number and a string name. Now, something important to note is, we have two favorite numbers here. Remember what we learned about scope? Since this favorite number is inside of these curly brackets, these would clash a little bit. So what we're going to do instead is we're going to rename favorite number up here to my favorite number, and we're going to copy paste that down here as well. So we're renaming this state variable, this storage variable, to my favorite number, and just keeping it down here. That way we can have favorite number inside of this struct. In any case, we created this new type of type person, which is a combination of each person has a favorite number and each person also has a name. Now, similar to how we can have a uint256, a Boolean, a string, an int256, etc., we now have a type of person, and this is similar to each one of these. Oh, and we're also going to have to update the retrieve down here with my favorite number instead of favorite number. Now, since we have our own new type, we can actually create a variable of type person the exact same way we created a variable of type my favorite number. So we could say person, visibility will be public, my friend equals, and we'll put person here and put some parentheses here, because when you're working with custom types, you have to define both on the left side and on the right side what type it is. And in here, we would assign a favorite number and a name. So we could say 7 and Pat, like that. So now Pat is going to be a person with a favorite number of 7 and a name of Pat. See, the first parameter goes to the first item in the person struct, and the second parameter goes to the second item. I like being a little bit more explicit when working with structs. And actually what you can do is you can put little brackets here instead, and you can say exactly what value you're going to assign to what section. So I can say favorite number is going to be 7 and name is going to be Pat. And we can hit Command S or just go straight to compile to see if it worked correctly, get that little green check mark. Now, by doing this, we've created our own type person, and we've created a variable named Pat with a favorite number of 7 and a name of Pat. Now, if we were to go ahead, let's delete this old simple storage and let's deploy our new simple storage. And we scroll down, we now have a new blue button since this is a public variable called Pat. And if we click the button, if we call this variable, we'll see favorite number of 7 and string name Pat. You can also see this 0 and this 1, which shows the index of each one of these variables or parameters. 0 is for favorite number, 1 is for name. If we added another one, maybe bool is cool would be at index 2. Whenever you create a custom type like this, Solidity will automatically index them, similar to the way that we index our lists or our arrays. Favorite number 0, name 1, whatever's next would be 2, etc. Now this is great for one friend, but what if you have a lot of friends, which I know a lot of you do because you're taking this course, which automatically means you're cool. Maybe what if you have your friend Mariah that you would like to add to our smart contract like this, and her favorite number is 16. Or maybe your friend John. You'd have to copy paste the line, add John in here. His favorite number is going to be 12, so on and so forth. It might get very tedious to have to write variables for all of these people, for all of these friends. This obviously isn't a great way for us to create lists of people or lists of our friends. So instead of this, we can actually use this array syntax that we just learned and create an array of person or a list of persons. So I'm going to comment all these out for now. And a quick tip here, if you're on a Mac and you highlight a couple of lines, if you're on a Mac and you hit Command / or Command ? It'll automatically comment or uncomment those lines. If you're on a Windows, I believe it is Control /, but you might be able to Google what the actual keyboard shortcut is. This is a keyboard shortcut I use all the time. So what we're going to do now is we're going to create a list or an array of persons. So exact same as we did it up here. We'll say our type first is going to be type person array. So we're a type person array. Then we'll state our visibility, which is going to be public. Then we'll get our variable name, which is going to be list of people like this. So we've created a person array with visibility public and the name list of people, and we'll just leave it blank for now. So it'll get defaulted to being an empty list, which would look like this. Now, if I were to go ahead and deploy this, let's delete the last one. Let's compile, deploy, we scroll down, we select this. We now see we have our retrieve blue button, and we also have this blue button for list of people. When you create arrays with a public keyword, instead of being able to see the whole array with this list of people button, you actually have to put in the index of the element you want to work with, and you get to see that exact element. It wants to take a uint256 as an input parameter. However, obviously, our array is blank. So if we say, what is the person at the 0th index? It'll say, well, nothing, because you have a blank array. Well, what about the first index? Well, nothing. What about the second one? Well, nothing. No matter what you put in the box right now, it's going to return nothing. We'll show you how to add to this array in just a second. This kind of array is known as a dynamic array because the size of the array can actually grow and shrink. In Solidity, a dynamic array is signified by what's inside of these little brackets here. If we added a 3 in here, this would be a static array. We're saying this list of people can only have a maximum size of 3. So we can only put 3 persons in this array. Dynamic array, static array. Can have any size, can only go up to 3. Any size up to 3, any size up to 4. Hopefully you get the picture. We're going to work with a dynamic array because we're going to want to add a arbitrary number of people to this person array. So let's create a function that will allow us to actually add people and update this array. And let's delete this comment. So below our retrieve function, we'll create a function add person. And this is going to take 2 variables as input. It's going to take the name of the person that we're going to add. It's going to take the favorite number of the person that we're going to add, as well as the name. So we'll say string memory name, and I'll explain this memory keyword in a little bit. And we'll do uint256 underscore favorite number. And let's do underscore name, and we'll make this a public function. And what we're going to do inside of this add person function is we're going to take this list of people object and call the push function on it. Arrays come built in with a function called push, which allows us to add elements or add person to our list of people array. So what we're going to do is we're going to say list of people dot push, and we'll add these little parentheses here, and we're going to push a new person onto this array. Now what we could do, now let's comment this out for now. Now what we could do is we could create a new person, new person equals person name favorite number, like we did above. Oops, excuse me, these are backwards. Person memory new person, which we're going to ignore that for now. And then just do list of people dot push new person. We could do this. This is valid syntax, and I'll explain this memory keyword in a little bit. This is going to create a new person, and we push to the list, or we could just add this person right into this push piece here. So we could delete this line. Instead of creating a new person on its own line, we could say list of people dot push person, and then we'll add in here favorite number name. Since we're calling this person favorite number name inside of this push object, Solidity is smart enough to execute this line of code first, create a new person, and then execute this line to push our person into this list of people object. So this function should allow us to push new people into our list of people array. So what we can do now is let's compile this. Let's deploy this. Let's delete the old one. We'll hit deploy. Now we see if we call our list of people at 0, we'll get nothing back because it starts off as a blank array. But now we have this new add person function where you can kind of see very faintly, it takes a string name and a uint256 favorite number. So we can add Patrick 7. We'll hit add person, which if you have your terminal, you'll see we made a transaction. And now if we hit list of people at 0, we see we have indeed added a person to the 0th index. Patrick has a favorite number of 7, and his name is Patrick. Obviously, if we hit 1, we'll get nothing back, and this will just stay up. But if we add another person, maybe John 16, add person, now at list of people index 1, we now see John 16. So 0, it's going to be Patrick 7, 1, John 16, 2 is nothing, so nothing happens. Now we've talked about this a little bit already, but if we go ahead, for example, and maybe delete this semicolon, and we go to try to compile, and we scroll down, you'll see we get this error. Parser error, expected semicolon, but got bracket instead. And it gives us this little red exclamation mark and the line that it's having an issue with. All these red errors mean that your code isn't compiling, and you can't actually deploy this to the blockchain because Solidity doesn't know how to turn this human readable code into machine readable code. So we need to add this semicolon here, recompile, so we get no errors. Now, interestingly though, if we go to the top and let's say we delete this SPX license identifier, and now we compile, we scroll down, we get a yellow box and it says warning instead of error. It says warning, SPDX license identifier not provided, source file, blah, blah, blah. Interestingly though, if we compile this, we actually, let's delete our last symbol storage, we can deploy this. So something important to note is warnings are just that. They're just warnings. They won't prevent you from deploying or compiling your code. Errors will prevent you from deploying or compiling your code. Now, even with that being said, though, it is good to try to remove all of the warnings because the warnings are generally there for a reason. They're warning you that you might be doing something bad. And sometimes if you have a bug in your code, simply just listening to the warnings would have solved it. So it's best to listen to the warnings here. So to summarize, if it's red, it's broken. If it's yellow, you might want to check it out. And additionally, when it comes to these errors and these warnings, this is where using our AI and Google searching skills can really come in handy. Let's say, for example, I ran our code, I get this error, I read the error, and I don't really understand what's going on here. What we can do is we could maybe copy this error and use any of these search features that we talked about. Resources for this course. We can use ChatGPT or Find, GitHub Discussions, Stack Exchange Ethereum, and Piranha. And I'll explain what each one of these is good for later in the course. But for example, let's go and try out Find. Find is an AI search engine for developers. What it does is it first does a Google search, and then it reads all those links, and based off the links it reads, it tries to give you an answer. So what we could do is we could say, I am getting this compiler error in Solidity. How do I fix it? We hit this little drop down, put any code or context here. We'll paste our error. This is the error, like this, and we'll go ahead and hit search. We get a pretty verbose response on what's going on with our code. We could actually take this a step farther, and we could copy our entire code base, and we could paste it under here. We say code. I usually put 3 backticks before and after any code that I use, and I'll teach you why in the future. Well, let's go ahead and hit enter and research. It actually is able to read our code and say, one way to fix the error is to simply add a semicolon at the end of the line where you push the new person to the dynamic array list of people. And we can see we do indeed get a way to just copy our add person function, and we can scroll down and just paste it on top with it being fixed. And we could also say concise because it's being a little too verbose for us. We'll hit enter again, and it wasn't that concise, but a lot of these AI tools, like I said, are still in beta. But this was a good example of how using an AI tool like this can actually help you detect bugs. Like I said, oftentimes they will still get things wrong, which is why it's important for you to know about GitHub Discussions, Stack Exchange, Piranha, etc. Later in the course, I'll explain more about how to ask good questions, how to do good AI prompting, how to format your questions, and how to search and learn more. One of the key pieces of being a really good software engineer or a good prompt engineer is less about actually knowing the information and more about knowing where to find the information. So throughout this course, I want you to practice using these resources because they're going to help you be a much stronger developer, much stronger prompt engineer, and just be better at everything that we're going to go over in this course. If Find or ChatGPT gives you a poor answer, be sure to use the GitHub Discussions. If you have a question specific to this course, be sure to use the GitHub Discussions. Or if you have a more general question about Solidity, about Foundry, or anything like that, you can use one of these resources. Again, I'll go over this more later. But great job. You've done your first bit of prompt engineering. Congratulations. You don't have to understand this section fully. Now, one thing that we didn't really go over and we kind of glossed over was this memory keyword. And you'll notice if we actually delete this keyword and you try to compile, we'll get an error. Data location must be memory or call data for parameter in function, but none was given. Now, there are actually 6 places you can store data in Solidity. You have the stack, memory, storage, call data, code, and logs. We're not going to go over all of these areas right now, but we are going to go over some of the big ones, which are call data, memory, and storage. And this is going to be a little bit advanced here. So if you don't understand this section the first time, don't worry about it. Just keep pushing through. It'll make more sense as you go later on in the course. Call data and memory both mean that this variable is only going to exist temporarily. It's only going to exist for the duration of the function call. Anytime we call add person with a different name, we can only access this name variable that one time that we call this function. If I call add name Patrick 7, and now I try to list of people at 0, obviously we see Patrick and favorite number 7, we can actually never access that Patrick variable ever again because it existed in memory. It existed for a very short period of time, just for that single call. We could also have call data here, and we'll go ahead, remove this, deploy the dropdown, and do the same thing. We'll add Patrick, and actually, you don't even need the quotes. Patrick, we'll do 88, add person, we'll see if it's in there. Sure is. Call data and memory both mean temporary variables. Inside of functions, most variables automatically default to memory variables. Strings are a special type in Solidity, so you have to specify memory or call data, and it has to do with the way arrays work in memory, but we'll talk about that much later in the course. Now, the question obviously then follows, okay, well, if call data and memory are both temporary variables, why have 2? What's the difference between these 2? Well, let's try something. Let's have this be a memory variable. And in here, we'll say name equals cat. So we're going to reassign whatever people put in here to cat. Let's compile this. Looks like it compiles fine. Now let's do call data and try to compile. We get an error. Type error. Type literal string cat is not implicitly convertible to expected type string call data. The difference between memory and call data is that a memory variable can be changed. It can be manipulated. If we pass a memory variable to a function, we can go ahead, memory, and I hit Command S to compile. This is valid solidity. This is not. If you pass a call data variable, you cannot modify it. Call data is temporary variables that cannot be modified. Memory is temporary variables that can be modified. And storage is permanent variables that can be modified. My favorite number was actually implicitly converted to a storage variable since it's added in this state context outside of a function. If you create a variable that's outside of any function inside of a contract, it'll automatically be a storage variable. And let's delete this line. Let's compile. Let's deploy again. Let's delete this, deploy. We know it's a permanent variable because we can hit retrieve and we can always access what is in favorite number. So if we store 1, 2, 3, we hit store, we can hit retrieve and we can access 1, 2, 3. So this variable 1, 2, 3 exists outside of function calls. Now, even though I said there are more places like stack, code, log, return, etc., we can only make these variables call data, memory, or storage. And like I said, we'll explain that later in the course. So let's go ahead, let's add this back to memory because that's normally what you'll see. Now, the next question that logically follows is, oh, okay, Patrick, well, why do we need to put memory here, but we don't need to put memory over here? In fact, if we try to put memory there, we get an error. Data location can only be specified for array, struct, or mapping types, but memory was given. Like I was saying earlier, arrays, structs, or mapping are considered special types in Solidity. And the way that memory management works under the hood makes it so that we have to put this memory keyword. uint256 is known as a primitive type, and Solidity is smart enough to know where to put this favorite number always under the hood. Like we were saying earlier, a string is actually an array of bytes, and so as we just saw with the error, we need to put the memory keyword for arrays. So then the next question is, okay, well, what about the storage variable? Can I put that here? No, you can't put that here either. Since this is a function, Solidity is smart enough to at least know that, okay, this is a temporary variable that you're working with. It's got to be memory or call data. It's not going to be storage, since this name is only going to exist for a short duration. So you got to pick one of these other two. So the summary of this section is that structs, mappings, and arrays need to be given this memory keyword. A string is an array of bytes, so it needs this memory or call data keyword. So this code is starting to shape up. It has a lot of functionality here. We can store variables, we can add people, but it has a bit of an issue. If we have this contract and we want to say, oh, what was Kelly's favorite number? Let's say we have 4 people in the array. Let's have Pat, 7, John, 8, Mariah, 10, and Chelsea, 22, or 232. And we ask the question, what was Chelsea's favorite number? Well, the way we would do it is we'd have to actually loop through this list of people to find Chelsea. So we'd say, okay, what's at 0? Okay, that's Pat. That's not Chelsea. What's at 2? That's John. What's at 3? That's Mariah. Or excuse me, what's at 3? That's Chelsea. Favorite number 232. Okay, perfect. I found Chelsea. But obviously, if we had 1,000 people in this array, that would be a very tedious process, and that would take a long time for us to find the person that we wanted. So the question then is there a better data structure than a list or an array to use that makes it much easier to access and find the information about the people that we want? And the answer to this is using a mapping. You can think of a mapping as a dictionary. It's a set of keys with each key returning a special set of information about that key. So it's similar to a dictionary. If you look up the word the word the will have a whole bunch of text associated only with the word the. So let's create a mapping type, and you'll see how it works in practice. So we're going to create a mapping like this with this mapping keyword, and we'll say the key is going to be a string, and it'll point to a uint256. So this is going to be our type. Obviously, what comes after the type, our visibility. So let's just go ahead and do public for this as well. And I like to be very explicit with my naming. So I'm going to say name to number, signifying that this mapping maps someone's name to their favorite number. And now with this, we have essentially a dictionary where every single name or every single string is going to map to one number. So for example, if we looked up Chelsea, we'd automatically get returned the 232 that we're looking for, instead of having to iterate through this list. So let's add some capabilities to our add person function here so that we can update our mapping. So we have this list of people.push, which adds someone to the array. Let's also update this so it will also add somebody to our mapping. To do that, we'll say name to favorite number, and we put these little brackets in here to specify what the key is, and we'll say underscore name, and we'll assign that to underscore favorite number. What this line is doing is now it's saying, all right, in our mapping up here, in our name to favorite number mapping, anytime you look for that person's name, you'll automatically get their favorite number back. And now you have a much quicker way to access people's favorite numbers just by knowing their name. So let's go ahead. Let's compile this. Let's deploy this. Let's delete our old one. We'll deploy this. Now we have this new name to favorite number blue button. And so let's go through the same problem. So let's say we have Pat 7, John 16, Mariah 32, Chelsea 232. Now, same thing, list of people 0 returns Pat, list of people 1, John, so on and so forth. Or we could just go down here and let's look up Chelsea, and we automatically get 232. We get Chelsea's favorite number back automatically. Same thing, if we look up Pat, we get 7. If we look up John, we get Mariah. And if we look up Cheesecake, we get nothing back. In a mapping, the default value for all the keys is 0. So if you look up a key or a word that we haven't added in the mapping yet, it defaults to the default value of whatever that type is. Since ours is a string to UAT256, UAT256 default type is 0. If we look for a key that we haven't added, we get 0 back. So now that we've added all this functionality, we're looking pretty good. We really like the way that our contract is set up. We have our my favorite number, which is a internal variable, but we have a way to read it with retrieve. We have our new typing person. We have a public list of people array. We've got a public name to favorite number. We've got a way to update the favorite number, retrieve the favorite number, and add people to both our list and our mapping. Now, in the future, you'll hear me say that you should never do this before you write any tests, before you get it audited. But for now, this is just a dummy contract that we're going to deploy on a testnet, so we don't really care. But let's go ahead and learn how to actually deploy this to a real testnet. This is going to simulate what deploying to a real network with real money is going to look like. Are you ready? You should be. This is going to be incredibly exciting. After you do this successfully, you should 100% tweet about it on Twitter, on LinkedIn, on Lens Protocol, on whatever social media you want. It's important to celebrate your small wins. Surprisingly, it'll help motivate you moving forward. So first off, let's make sure this actually compiles. Okay, cool. We've got a green check mark. There's no warnings. There's no errors. Fantastic. Now let's go back to the deploy tab and we'll delete this down here and we'll scroll up and we're going to change the environment. We're in this Remix VM and we're actually going to move to injected provider MetaMask. Remember, this Remix VM is kind of this fake world that Remix gives to us. Injected provider MetaMask means that we're going to literally inject our MetaMask into this Remix. We're going to inject our MetaMask into this website. We're going to allow this website to interact with our MetaMask. We'll first get prompted by MetaMask to pick the account we want to use. I'm going to use account 1 and hit next. And we're going to go ahead and hit connect, similar to the way we connected to the faucet. If we scroll up to our MetaMask, we now see, oh, it says your account is not connected. That's because I'm currently on account 2. Let's flip to account 1. And we do indeed see that account 1 is connected. And now before, where we saw kind of this fake account with fake ether, we see our actual account with the actual amount of Sepolia ETH that we have. Make sure that, again, be sure to use whatever recommended testnet we have in the GitHub repo. For us, we're using Sepolia. Don't worry about the rest of these for now. So make sure you're on the correct testnet. To deploy to a testnet, you're going to need some Sepolia ETH. So if you haven't been to the faucet, be sure to head over to the faucet to get some Sepolia ETH. Remember, you can find those in the GitHub or web3dev.education. Now in Remix, What we're going to do the exact same process we use to deploy to the virtual remix environment. We're going to do that to deploy to the testnet environment. So we're going to go ahead and hit the deploy button, and MetaMask is actually going to go ahead and pop up. This is similar to what we saw with the blockchain example with signing transactions. We're actually going to sign and send a transaction on the testnet. It's similar, again, to us sending Ether to ourselves. The difference here is, though, that our data section has a ton of information here. All this data is associated with sending this transaction, but this one has all of this contract information encoded in machine-readable code, or our compiled code. In details, we can see all the payment information associated with this transaction. We can see exactly how much gas it's going to cost to deploy this contract on-chain. But again, we're on the Sepolia test network, so this is fake money anyways. To actually deploy this, we're going to go ahead and hit the confirm button, and now we're going to have sent our function. If you have the terminal up, you can see we have this call created, and it says creation of simple storage pending with this view on Etherscan button. If you click the view on Etherscan button, you'll get brought to this Etherscan page with this transaction going through on Sepolia. You'll see it's currently being indexed by Etherscan, but there's a good chance it already went through. And back in Remix, it actually goes ahead and gives us this green check mark saying that we did indeed deploy this contract. You might have to wait a few minutes for this to complete because, again, we're sending a transaction to a testnet blockchain, and the blockchain needs to actually produce the block with our transaction in it. But if we wait a few minutes on Etherscan, we'll eventually see a success status with block confirmations on this block section here. And exactly the same as what we saw with sending ETH to ourselves, we see all this information about the transaction hash, status, block, time, from, to, blah, blah, etc. But if we scroll down, this input data field is much bigger than anything we've seen before because, again, this is all the data associated with creating this contract. And of course, we see more gas fee information because, again, deploying a smart contract to the chain is modifying the blockchain, so we have to spend gas. Now, if we come back to our remix and scroll down, we're able to see our simple storage contract, and we're able to copy the address that it's at. So if we copy this address, we go back to Etherscan, we can even paste this into the bar here, and we can see this contract that we went ahead and deployed. Etherscan is smart enough to know that this transaction created a new contract. Remember, this has to be on the Sepolia Etherscan, not the mainnet Etherscan, because we sent this on the Sepolia testnet. So now that we have this contract created, we have all the exact same functions that we had in our virtual environment, but these functions are actually on a testnet with a contract that we actually deployed. Now we can do all the exact same things we were doing on our fake remix environment on this testnet environment. For example, we can call retrieve, which doesn't send a transaction. It just reads off the blockchain, and we get 0, same as what we got before. If we look up a name like Pat, in name to favorite number, we get nothing back because we haven't updated anything. If we add 0 in here for list of people, we get nothing back as well. MetaMask didn't pop up here because these blue buttons are view functions. View and pure functions, like we said, don't send transactions. Now let's go ahead and actually send a transaction. Let's update the blockchain. Let's update our contract by storing a new favorite number. So let's do 7878 and we'll hit store and we'll press this orange button. You'll see you'll get prompted with MetaMask actually popping up saying, okay, let's update the blockchain. Let's send this transaction. And if we go ahead and hit confirm, the exact same thing happens. We'll get this transact to simple storage, transact to simple storage.store pending, view an Etherscan, this little check mark. If we view it, we can see the transaction indexing on Etherscan. And after you wait for a little bit, the transaction will go through. And now if we hit the retrieve button, we can see we have now stored 7878 on chain. If we copy the contract address again, we paste it into Sepolia Etherscan, we scroll down, after a few minutes, we'll actually see a second transaction come through. We see 2 transactions associated with this contract. The first transaction obviously is the contract creation transaction, and the second transaction is us actually calling the store method. Etherscan is smart enough to know that this is the store method. It's not always smart enough to know that, but for this one, it's smart enough to know. And we see that we actually updated our contract. And remember, in the future, please use these testnets sparingly. We're just starting out and we're just learning, so it's okay for us to send these transactions here though. But let's go ahead and let's keep going because name to favorite number of Pat still returns nothing. List of people 0 still returns nothing. So let's go to add person. We'll do Pat 16. We'll hit add person. MetaMask pops up, obviously, because we're updating the state of our contract. We'll hit confirm. We see transact to simple storage.add person is pending. It looks like it has succeeded. So now if we do named favorite number of Pat, we see 16 get returned. And if we do list of people at 0, we see we get Pat, whose favorite number is 16. And guess what? At this point, you've successfully deployed a smart contract to a real testnet. Congratulations. You should be incredibly excited for yourself. Be sure to give yourself a pat on the back, maybe go for a walk, maybe have an extra cup of coffee or an ice cream. Because additionally, you've also interacted with that contract with these buttons in Remix that allow us to send transactions to update the state of our contracts. Congratulations, you're a Solidity developer. But we've got a lot more to go. And like I said, make sure to celebrate these little wins. Celebrating little wins will motivate you and excite you to continue to move forward. So be sure to take the time to pat yourself on the back. Congratulations if you've got this far. There's a ton more for us to learn, but just you getting here is a fantastic achievement in itself. Now here, if we wanted to deploy to a different testnet, all we would have to do in our MetaMask is switch to a different testnet like Linea Gorilli. Since we don't have any Linea Gorilli, we actually can't deploy this to a testnet, but if we used a faucet to get more Linea Gorilli ETH, that's how we would deploy it. Additionally, we could do the same methodology for deploying to Ethereum mainnet or any other mainnet that you want to work with throughout this course. The difference here is obviously you just need to buy some Ethereum to actually deploy this smart contract. Remix will automatically update to whatever network you're working with. For example, right here it says, you're working on the main network. But if we were to switch to Gorilli, it would say, you're working on Gorilli. But if we were to switch again, it would say, you're working on Linea. In the future, we'll learn to add different networks so you can learn how to deploy to any other EVM compatible network that you want to. Now, I've mentioned this a couple of times, but whenever we compile this code, it compiles it down to something called the EVM or the Ethereum virtual machine. Don't worry too much about exactly what this means, but essentially the EVM is a standard for how to compile and how to deploy smart contracts to a blockchain. Any blockchain that is EVM compatible, you should be able to deploy Solidity code to. Some examples of EVM compatible blockchains and layer 2s, which again, we're going to go over working with layer 2s more in the future, are going to be Ethereum, Polygon, Arbitrum, Optimism, ZK Sync, and more. Just note that it's important to double check the blockchain before you launch to it. For example, ZK Sync is EVM compatible, but a couple of keywords don't actually work with ZK Sync. Now let's do a quick recap of everything we learned in this lesson. And then after we do this, be certain to take a break, maybe go get some ice cream, go get that extra coffee or whatever you like to do. The first thing you want to do in any smart contract or Solidity code that you write, be sure to write the version that you want to work with. And above the version, be sure to add the SPDX license identifier. If you're not sure what version to use, for now, just default to MIT. Then you have to create your contract object and name your contract. A contract is similar to a class in other programming languages. Anything inside of the curly brackets for the contract is part of that contract. There are many different types in Solidity, like uint256, string, boolean, int, etc. If we want to create our own type in Solidity, we can use what's called a struct. You can create arrays or lists in Solidity. You can create mappings or dictionaries or hash tables in Solidity, where if you give it a key, it'll spit out the variable associated with that specific key. We can create functions in Solidity that modify the state of the blockchain. We can also create functions in Solidity that don't modify the state of the blockchain. View and pure functions don't modify the state of the blockchain. We can also specify different data locations in our parameters of our functions, but we can only do that for special types like strings, structs, and arrays. Call data and memory mean that that variable is only temporary and will only exist for the duration of the function call. Storage variables are permanent and stay in the contract forever. Function parameters can't be storage variables since they're only going to exist for the duration of the function call. Whenever we hit compile in our smart contracts, it actually compiles our Solidity code down to EVM compatible bytecode or machine readable code. We'll learn more about those specifications later. And last but not least, congratulations on your first contract here. All right, let's get started now with our lesson 3. Remember, everything is in the GitHub repository or the web3dev.education. If we scroll down, once again, we can scroll to lesson 3. And again, a lot of this is undone, but it'll be done for the actual video. Scroll down to lesson 3, and we have lesson 3, Remix Storage Factory. All the code that we're going to be working with is in this Remix Storage Factory F23 GitHub repository. All of the GitHub repos associated with this course end with F23, which stands for Foundry 2023. I'm going to first do a brief walkthrough of what we're going to be coding for this lesson. So for now, just sit back and relax and enjoy. For this lesson, we're going to be working with 3 new contracts. Our original simple-storage.sol, which we're going to do a slight modification to, a new 5storage.sol or add 5storage.sol, and a storagefactory.sol. Our storagefactory.sol is actually going to be responsible for deploying new simple storage contracts. Yes, other contracts can deploy contracts. Not only is this going to be able to deploy other contracts, but it's going to be able to interact with other contracts as well. What we could do is we could deploy this to a Remix VM, hit deploy. We'll compile all of our code, go to a Remix VM, scroll down to select the contract. We're going to select Storage Factory, not Simple Storage. Deploy this, see that contract that we just deployed down at the bottom. And you'll see our top function is this function called Create Simple Storage Contract, where if we pull up our terminal and we click Create Simple Storage Contract, you'll see we get a new transaction at the bottom. And this transaction is the transaction that we deployed a simple storage contract from our Storage Factory contract. Now we can actually go ahead and interact with our simple storage contract. Remember, in simple storage, we have a function called store, which takes a favorite number. We can actually call this store function on our simple storage contract from our Storage Factory contract using this fstore function. So we'll add the index of our simple storage contract, which since we only deployed 1 so far, it'll be at index 0. And we'll say our new favorite number is 123. And we'll hit fstore, and we'll click sfstore at 0123. sfstore stands for Storage Factory Store. So we're going to store the number 123 on index 0. And again, don't worry about this making too much sense yet. We're going to explain this all in a minute. Now, if we hit sfget of 0, we'll go ahead and get back 123. We're saying let's get the value of the simple storage contract stored at index 0. And we do indeed get 123. Additionally, we have this list of simple storage contracts, array or list, and it's only size 1 right now. But if we type in 0 here, we get back the address of that original simple storage contract that we deployed. Additionally, in this lesson, we're going to learn about a ton of incredibly important Solidity features, such as imports and inheritance. Without further ado, let's get froggy. And one more time, of course, remember all the code is available in the Foundry full course F23 of the ChainXL org or on the web3dev.education site once it's up. So here we are back in Remix with our simple storage.sol. If you skipped over the last section and want to get that contract, just come to the full repository, go down to lesson 2, go over to the code in the GitHub repo associated with this course, the Remix Simple Storage F23, and just copy and paste everything into Remix yourself. To make sure you've done it correctly, be sure to hit compile. We have our simple storage contract that we created in our last lesson, which is great. It allows us to store our favorite number, and it allows us to store a list of people who have different favorite numbers, also a mapping, and some other different functionality with interacting with people's favorite number. But we want to go even further with this. We want another contract to actually deploy this simple storage contract for us and interact with it. Contracts interacting with each other seamlessly and permissionlessly is a feature of smart contracts and blockchain development that's absolutely essential and crucial, and one of the reasons why blockchain development is so powerful. The ability for contracts to interact with each other seamlessly is something known as composability. Smart contracts are composable because they can easily interact with each other. This becomes even more important when we get to topics such as DeFi, where we can have incredibly complicated financial products and instruments interact with each other seamlessly because they're all using the same smart contract interface. So we're going to keep our simple storage.sol the exact same way it was from the last lesson, and we'll update it in a little bit. But let's go ahead and create a new contract called storagefactory.sol. So let's go ahead and get this contract set up. Now we're going to be doing this a lot, and when we work with AI pair programming, this is going to be a lot easier for us to do. But for now, repetition is the mother of skill, so let's keep going. First thing we need to do is what? If you want to pause the video and add the first 2 things you should put at the top of every Solidity smart contract right now, go ahead. But for those of you who didn't pause, let's go ahead and do spdx license identifier MIT, and then let's do pragma solidity 0.8.18 or 19 or whatever you want to do. You know what? Let's do 19. What did we do in simple storage? We did 18. Let's do 18. And then we'll do contract. So this will be the third thing actually. Contract storage factory like this. And I hit Command S, but you can also go and compile like so. And I'm also just going to add the caret here, meaning we're going to use 0.8.18, but any version greater than that also works as well. Awesome. Now this storage factory contract is going to be deploying a simple storage contract. So let's create a function that can actually deploy or create a simple storage contract. So we'll say function create simple storage contract, and we'll make this a public function. And we're going to have this create simple storage contract function deploy a contract and then save it to a state variable or a storage variable. But the question is, okay, well, how does the storage factory know what the simple storage contract even looks like? How does this contract know about this contract? How does this contract know that this contract even exists? The first way that we could do this is we could actually go to our simplestorage.sol contract and start highlighting from the contract word and scroll all the way down to the end of the contract, copy it, Command C or right click, copy, go back over to storage factory, and below Pragma Solidity, but above contract storage factory, paste it in here. If we go ahead and Command S or compile this, you'll see that this actually goes ahead and compiles successfully. So this is to show you that yes, right now in our storage factory.sol, we have contract simple storage, which ends here, and we also have contract storage factory down here. You're allowed to have multiple contracts in the same file. Now, this isn't a best practice because we really don't want to be having multiple contracts in the same file when we could separate them out into their own files. As your projects get bigger and bigger, if you just add all of your contracts into the same file, it can get really, really confusing and really difficult to jump around the code and find the places where you want to add stuff. So normally it's best practice to keep them separated like we did above. But we'll learn a little bit more about how to keep them separate in just a minute. If you go down to the deploy tab and you stay on the Remix VM and scroll down, you actually have this section to choose your contract. We can choose either one of these contracts right now. And if on the right side you have storagefactory.sol, in this contract section, you can actually choose either one, simple storage or storage factory, and you can see they're both in storagefactory.sol. If on the right-hand side, we go to simple storage and we go back to this contract section, we can only choose simple storage because the simple storage contract only has one contract in it. The storage factory has both simple storage and storage factory. So that can get a little confusing as well if you have multiple contracts in the same file. But let's stick with this methodology for now. In our storage factory, and let's even close out simplestorage.sol at the top just so we don't get confused. In our storagefactory.sol, let's scroll back down to storage factory, because now that we have our simple storage in this file, we can actually deploy the simple storage contract. So this function is going to deploy a simple storage contract, but we're going to save it to a storage or state variable. And we're going to do it the exact same way we've been saving any variable. First thing, remember how we did uint256 public favorite number? This was in the format type, visibility, name. We're going to do the exact same thing. The type of a simple storage contract is going to be simple storage. And the reason that Solidity is going to be able to identify this keyword is because it's the same name as contract. In the same sense that our struct keyword allows us to create a person type, the contract keyword allows you to create a new type of a type of simple storage contract. So simple storage, for now, we'll just give it a visibility of public, and we'll give it a variable name, simple storage. Now, this is going to be a syntax you're going to see a lot, and it might be a little bit confusing the first couple times you read it. The difference between these two is very subtle. The difference between simple storage on the left and simple storage on the right is very subtle. It's simply that the S is lowercase over here, and the S is capitalized over here. Solidity is case sensitive, so these are actually different words. Simple storage here is referring to the contract. Simple storage here is referring to the variable. You'll often see people use the syntax when working with contracts where they name the variable the exact same as the contract itself. If this is confusing to you, you can do my simple storage instead of simple storage with lowercase. So either one of these works. It's good to get used to this as such, but if that's confusing, you can do my simple storage. Now in our create simple storage contract function, we're going to say simple storage equals new simple storage like this. This new keyword is how Solidity knows to deploy a contract. So with just this code alone, if we go to the compile tab, we compile this. This does indeed compile. We can go to deploy. We need to make sure we're on the storagefactory.sol on the right-hand side. We'll scroll down to the contract. We can actually deploy our storage factory like so, hitting the deploy button. And remember, you can see the transaction in the terminal here. And we can scroll down to the contract. Right now, there's two buttons. We have our blue view function, simple storage, because again, the public keyword automatically gives the variable name a getter function or a view function. And of course, we have our create simple storage contract, orange button, because it is actually a transaction. Right now, simple storage returns nothing, the zero, the default value for an address, which is the 0 address. And if we call create simple storage contract, we see a green check mark, meaning that transaction went through. Now, if we call the simple storage blue view function, we see we indeed get an address here. We have deployed our simple storage contract from another contract. Oh my goodness. So congratulations. Now you know how a contract can deploy another contract. Awesome job. But the thing is, like I was saying, if we just add all of our contracts into the same file and we have these massive contracts all interweave between each other, it can get very cluttered and very confusing. So is there a better way we can actually arrange and organize our code other than this? And this is actually even a little bit redundant since we already have our simple storage.sol. If I change something in here, then I would also have to go and change it in here. And that's too much work for me. As an engineer, I will work incredibly hard to be incredibly lazy. So instead of doing this, we can use what's called an import. If we go ahead and delete our contract simple storage in our storage factory here, so that now we just have the storage factory contract, we can go ahead and use the import keyword to import simple storage.sol. So we can do import /simple storage.sol and a little semicolon here. This import /simple storage.sol is the exact same as if we had this giant simple storage in here. So this import simple storage.sol is a shorthand version of copy pasting that simple storage.sol into this contract. And now we're able to have simple storage.sol in its own file and storage factory just import it from simple storage, making our lives much easier. It takes our path, package, or GitHub, which we'll explain in a little bit, and copy pastes whatever in that file at the top of our file. Literally, Solidity for us is copy pasting everything in here and sticking it up here. So we can go ahead and run this again. Let's compile, delete our old contract, run Remix VM. Let's be sure we're on Storage Factory. We'll go to Storage Factory, we'll deploy it, scroll down, click here. Simple storage starts up as nothing, create simple storage. Oh my goodness, look, we deployed a contract. Huzzah. Great work. So now that we're starting to work with different files, there's a number of things we want to consider. The first one is actually the Solidity version. So right now we're using 0.8.8 with no caret, and in Storage Factory we're using 0.8.8 with a caret. If I were to, for example, move the Solidity version of this down to 0.8.16 and go to compile this with a different version, Remix is actually going to automatically bump this up to 0.8.19. Or actually, Remix is actually going to automatically bump this up to 0.8.18 if I'm on the simple storage, because 0.8.18 is the version that works for simple storage, and it still is compatible with Storage Factory. However, if I were to take Storage Factory and move it to 0.7.6 and try to compile, it's going to try to compile this with 0.7.6 and our simple storage with 0.7.6. And it's not going to be able to do it for both. And so we're going to get a compilation error. So when working with multiple files, it's important to keep the version of Solidity in mind because you want to make sure that all of your contracts can actually compile together. So this is great and all, but right from the get-go, I want to teach you the more advanced import that you should always use. So this is good, but we actually never want to default to this. We want to default to something called named imports. Let's say our simple storage.sol contract had a ton of other contracts, like contract simple storage 2, simple storage 3, simple storage 4, and these were all massive, massive contracts. As we have this right now, import simple storage.sol would import everything from here. Simple storage 2, simple storage 3, simple storage 4. And if these files were incredibly big, when we deploy our storage factory, it would have to calculate all this extra computation, making the deployment of our storage factory more expensive. If that's confusing to you, don't worry about it right now. Additionally, in the future, these can import from weird places that aren't compatible with Storage Factory. Again, that's not going to make sense quite yet, and that's okay. But in any case, there's a way for us to not import this whole file, but only a very specific contract or a specific section of our simplestorage.sol. So instead, what we can do is in our import statement, we can specify the exact contract that we want to import from this file. So in our simplestorage.sol, let's say we do have these other contracts in here. We could say we only want to import simple storage, not simple storage 2, not simple storage 3, not simple storage 4, by saying import these little brackets here, simple storage from simplestorage.sol, and this goes ahead and compiles correctly. We could also import multiple contracts from our simple storage. For example, we could do import simple storage 2 from simplestorage.sol. This way, we only import the exact specific contracts that we want from these other files. And I promise you, in the future, always referring to named imports instead of this type of imports will save you a lot of headache in the future. So always default to this, never default to this. Just by learning this, you are already better than 80% of the current Solidity developers. So congratulations. But all right, fantastic. So we've learned about imports. We're able to import our simple storage from simplestorage.sol. We're importing it in the more advanced way. Congratulations. Now, already here, you might actually start running into some questions, right? And we're going to get more and more advanced with this course, and you're going to have questions, which is a good thing. If you don't understand stuff, that means you're thinking critically and you're approaching the subject matter the right way. So this is where we're going to jump into, again, doing a little bit of an AI chat example. So for example, on this line, let's say you're a little bit confused and you go, what's the difference between simple storage here and simple storage here? I don't understand. So let's learn how to work with ChatGPT or any AI buddy to ask them to help clarify. So we're going to go ahead. I'm going to hit Command A, or you can just highlight everything, Command C to copy, or right click copy. We'll go over to ChatGPT, and in here, we're going to ask the question. Hi, I'm having a hard time, and let's zoom in, understanding the difference between the simple storages on this line. And here's where we want to be very specific when we're talking with AIs. So I'm going to hit Shift Enter so that it doesn't actually send the question to ChatGPT, but I'm going to put 3 backticks, Shift Enter again, and actually I said we're going to copy the whole thing, but let's just copy this single line and paste it in here. Shift Enter again, 3 backticks again. Adding this delimiter tells ChatGPT that this is a block of code, and it makes it easier for ChatGPT to be able to understand that this is a block of code. Then I'll hit Shift Enter twice. And if you have a lot of code, you're not going to be able to copy your whole contract because a lot of these AIs can only understand so much in a question. But this is small enough that we can actually just go ahead and copy the whole thing, bring it back over to ChatGPT, and say, here is my full code. And then we'll do again, Shift Enter, 3 backticks, Shift Enter, paste, Shift Enter, 3 backticks. So now we have a little AI prompt here that we can ask in ChatGPT. And I don't have this in here yet, but in the GitHub repo associated with this lesson, I will add this AI prompt in here. So let's go to the bottom. And I was saying you needed to use Shift Enter, but I guess you could just use Enter. That's fine. Let's go ahead and click the send button and it'll send it the question. So now it'll start outputting here and let's see what it says. And this is where we can already start to see the power of these AI buddies as learning buddies. We see in the given code, simple storage is a variable of type simple storage, which is a contract defined in simplestorage.sol. It tells us what the line is doing. It clarifies the differences a little bit more. And a lot of this beginner basic stuff, AIs are really good at. Once we get more and more advanced, AIs are going to start breaking apart. But at least for the beginning of this course, AIs are going to be incredibly helpful and incredibly good at explaining a lot of these. What we could do if we wanted to is we could also go ahead and copy this prompt. We could go over to something like Bard, paste it in here, and ask Bard the same thing. And here's already a good example of where an AI can get things wrong. If we scroll down, it's telling me you can use simple storage variable to interact with the new simple storage contract. For example, you could call the set function to set the value on stored data variable, or you could call the get function to get the value of the stored date variable. There is no stored data variable, so I don't know where it's getting that from. So just remember, keep in mind that AIs can get things wrong, and that when they do, there are other forums to use as well. Like I said, we're going to be learning about them as we go on, like Stack Exchange Ethereum, Piranha, or like I said, of course, the discussions forum of this course. So if Bard or ChatGPT or whatever AI buddy you're working with gives you something confusing, be sure to go to the GitHub discussions or ask on one of these forums. Now, as you can see though, right now, every single time we call create simple storage contract, we're going to deploy a new simple storage contract, but we're going to override it in this simple storage, right? So if we go ahead and deploy this right now, we'll scroll down here, simple storage at the 0 address, create. Okay, now it's at a new address, create again. Okay, now it's at a new address. We're not keeping track of all the different addresses that this simple storage contract is being deployed to. So let's actually create a running list of all the different simple storage contracts that we're deploying. So instead of having this variable be just a single simple storage contract, let's have it be an array or list of simple storage contracts. And we'll change the name to list of simple storage contracts. So now when we deploy it, instead of saving it like this, we're going to do what we did before in our last section. We'll say simple storage, new simple storage contract equals new simple storage, and then we'll push it onto our dynamic array. So we'll say list of simple storage contracts, push new simple storage contract. So let's go ahead and compile this. Okay, looks good. Let's go ahead and deploy this. We'll delete our old one. We're on the Remix VM. Great. Storage Factory. And look at this. You can even see, make sure we're on Storage Factory. Okay, great. We'll go ahead and deploy that. Awesome. We get list of simple storage contracts, which now has this uint256 input, which allows us to choose the index of the variable. We'll go ahead and create simple storage. Now, if we go check the 0th index, we have an address. If we check the first index, nothing happens. If we call create again, which, sorry, if I have the terminal up, I'll call create again. Now there is one at the first index. And since I called it twice, there's also one on the second. There's nothing at the third. I'll hit create again. There's no one at the fourth. Oh, at the third, excuse me. Awesome. So now we actually have a running list of all of our simple storage contracts. Now let's learn how to actually interact with other contracts from a contract. For now, we can think of our storage factory as a sort of manager for all these other contracts. So let's learn how our storage factory contract can actually call the store function of the simple storage that it deploys. So let's create a function called sfstore, which is going to stand for storage factory store. And it's going to take two variables, a uint256 underscore simple storage index and a uint256 underscore new simple storage number. We'll make this public like this. Now, in order to interact with a contract, you're always going to need two things. And we're going to refer to this a lot. You're going to need an address and you're going to need the ABI. Now, this is technically a lie. You really just need the function selector, but we're going to learn that way later in the course. For now, just think, okay, I always need the address and I always need the ABI. The ABI stands for Application Binary Interface. The ABI will tell our code exactly how it can interact with another contract. We'll go deeper into the ABI later on in this course. But for now, if you go to the Compile tab, you hit Compile, and you scroll down, there's this little button at the bottom that says Copy ABI to Clipboard. Or you can also go to Compilation Details. You can see a ton of information about the compilation details, such as the bytecode with the opcodes, some metadata of the name, but also the ABI, which tells us the ways we can interact with this contract. If we hit the drop down for the 0, we see there's an input, create simple storage contract, which is one of our functions. And you see state mutability, which we'll talk about later. But if we hit another drop down, we see list of simple storage contracts. And the other drop down, we'll see sfstore. These, as you know, are the buttons that we can press when we deploy this contract, right? So if I redeploy this, we see those exact three buttons. These are the three buttons that were inside of that ABI. This is how Remix knows to put three buttons here because it looks at the ABI and sees that there's three buttons. So in our code here, our compiler knows what the ABI is. So in our code here, the compiler automatically knows what the ABI is because the compiler is the one that generates the ABI. And we know where the address is because we have a list of all of our addresses that we're keeping track of up here. So the reason we have the ABI is because we're importing our simple storage contract. And actually, let's delete this simple storage too. We don't really need the simple storage too. So when we compile simple storage, we automatically get the ABI for Solidity. In the future, we'll learn other ways to get the ABI. So down here, let's get a simple storage contract to interact with from our list. And to do that, we'll say simple storage, my simple storage equals list of simple storage contracts at index simple storage index, like this. Since this is an array of simple storage contracts, we can just automatically get the contract itself like this. However, let's say that instead of this being an array of simple storage contracts, this was an array of addresses, called list of simple storage addresses, like this. You don't have to code along with me for this section, just go ahead and follow along and watch. If we had a list of addresses, and this would need to be a little bit different, but if we had a list of addresses instead, we could say simple storage, my simple storage equals list of simple storage addresses at the index, and then do something called typecasting. And we'd wrap this in parentheses like so. Let me zoom out a little bit. So this is something we'll learn about a little bit later. So basically what we're doing is this list of simple storage addresses, simple storage index, this line returns an address, and we're wrapping that address in simple storage like so. If this is a little confusing for you now, don't worry too much about it. We will learn about it more later. Now that we have our simple storage contract, we can actually call the store function directly on this contract. So now we can say my simple storage dot store, and we'll add the new simple storage number. And this is great. If we were to deploy this contract right now though, and call this SF store function though, we wouldn't be able to read the new variable that we just updated our simple storage contract with. So let's create a function that allows us to read from our simple storage contracts as well. So we'll create a function called sfget, which will take a uint256 underscore simple storage index is an input parameter. We'll make this a public view function that will return a uint256, and we'll say simple storage, my simple storage equals, and we'll use this exact same syntax that we used above to get the simple storage index, equals list of simple storage contracts at the simple storage index. And now we're going to do return my simple storage. And again, if you see these autocompletes that come up, you can just hit tab, but dot retrieve. So perfect. Now let's go ahead and compile. We'll go ahead and delete the old deploy. We'll make sure we're on storagefactory.sol. We'll hit deploy, and we see storage factory down here. Now let's go ahead, run through that exact same exercise. So we'll pull up the terminal just to see our transactions go through. We'll hit create simple storage. Let's see that it's actually there at the 0th index. Okay, cool. We see an address there. So now let's store a new variable at index 0. So at this address. So we'll say at index 0, we'll store the number 123. And actually before I hit this button, if we go down here, we hit 0, we get nothing back, right? But now if I hit sf store with index 0, favorite number 123, looks like the transaction did go through. Now if I hit sf get, we go ahead and get 123. So our storage factory contract was able to create its own simple storage contract, store a variable in that contract from the storage factory, and we were able to read back the number 123 all from within our storage factory contract. Feel free to pause right now and play around with adding different values, creating different simple storage contracts so that you really understand what's going on. You can also feel free to hit the little drop downs and read more information about these transactions. Just as a recap, in our storage factory contract, we have a function called create simple storage contract, which creates new simple storage contracts from the storage factory contract. The reason it's able to do this is because we're importing from our simple storage.sol file using something called named imports. We're only importing simple storage. We're not importing anything in these other contracts. Then we use sf store to store a new number on one of those simple storage contracts using the index in our array. It can do this because we have the address and the ABI. The list of simple storage contracts automatically compact with the address and the ABI. And then finally, we can read back those simple storage values that we stored. Now we can make this sfget function even more condensed. Since this list of simple storage contracts, simple storage index, returns an object of type simple storage, we can actually delete this whole line, copy this, paste it here, and delete this line. And this will work exactly the same as what we had before. Go ahead and save or compile, you'll go ahead and get that green check mark there. This dot retrieve is saying we're going to call the retrieve function on whatever this is. And this, whatever this is of type simple storage contract. We can actually do the same thing up here by deleting this part, copying this line, except for the semicolon, and pasting it over the my simple storage and hitting save or compile. Awesome. Great job so far. Awesome. Now, let's say you really like this simple storage contract. You love all of the functionality except for one thing. You wish that the store function didn't just store the favorite number, you wished it added 5. So for some reason, you want a contract that does everything this contract does, but just adds 5 whenever you call store. For some reason, you want everyone's favorite number to be 5 larger than what they think it is. Well, one thing we could do is we could just copy paste this into a new file. But again, that's kind of too much work for me. I'm a lazy engineer. But let's go ahead and see how we can approach this problem. So let's create a new file and we'll call it add5storage.sol. And same thing, since this is a new contract, we're going to follow the exact same tips. We're going to do spdx, license identifier, MIT. We're going to do pragma solidity, 0.8.18. Let's even do the little caret here. And we'll do contract, add 5 storage, like so. We'll hit compile. Great, looking good. Oh, I'm getting a warning. spdx license, spelled license wrong. So let's spell that right. Okay, cool. Looks good. So like I said, the first thing that we could do is we could copy paste everything in here and then just change the pieces that we don't like in our add5 storage. This is a little bit redundant, a little bit too much work, and we are engineers. We want to work as hard as possible to be as lazy as possible. So how can we do that? Well, this is where we can do something called inheritance. We can have our add5 storage contract be something called a child contract of our simple storage contract. And we can have our add5 storage inherit all of the functionality of our simple storage contract. So first, of course, in order for our add5 storage to know about our simple storage contract, we're going to go ahead and have to import it. So we're going to do import, and we're going to do, once again, the named imports because we're advanced Solidity engineers. So we're going to say import simple storage, just the simple storage contract from /simplestorage.sol. Now, if this / is confusing to you, don't worry, we'll learn about directory structures later on in the course. And then we'll say our contract add5 storage is simple storage. Now our add5 storage is going to do what's called inherit everything from simple storage. And our add5 storage is going to have all the same functionality as simple storage. We can actually see this directly if we go to compile. Let's go ahead and delete our previously deployed contracts. We're on the Remix VM. Let's make sure we've selected add5 storage, add5storage.sol. Let's go ahead and deploy it. And if we scroll down, we can actually see, oh my goodness, it's got all the same buttons as simple storage, even though the contract itself doesn't have anything defined. That's because we inherited all of the buttons. We inherited all of the functionality of simple storage into add5 storage. If you want a contract to inherit the functionality of another contract, you just import it in and then say your contract is that other contract. Now we can keep going though and add our own custom functionality into add5 storage that's not in simple storage. So for example, we could say function, say hello. It's going to be a public and it returns a string memory. And again, you need the memory keyword because strings are special in Solidity. And we could just say return hello, like so. This will be a public pure. It's not a view because we're not reading from storage. And again, if that assertion is a little confusing to you, don't worry too much about it now. But if we go to deploy it, let's delete our old one. We'll deploy this one. We see we have all the functionality of simple storage plus this say hello function. Great. But let's delete that for now. Let's say instead of wanting to add additional customization, you actually love every function in here except for one. Remember, the reason we wanted this add5storage.sol is because we actually want to change the store function to have it add an additional 5 to people's favorite numbers. Maybe you're mischievous and you want people's favorite numbers to be 5 greater than they are. Well, to add this add5 customization to that store function, we can do something called overrides. To do overrides, there are 2 keywords that we need to be aware of. Those are virtual and override. If I were to try to create a store function for our add5 storage right now, what do you think will happen? Well, let's try it out. So let's say function store uint256 underscore new number public. If we try to compile this right now, we'll actually get an error, even if there's nothing in this store function. We roll over, we say, from Solidity, type error. Overriding function is missing override specifier. And remember, if you get lost or confused, an error like this is something perfect for you to ask ChatGPT or maybe even find. We could say, I am trying to compile my Solidity code, but I'm getting this error. We can copy this whole error here, paste it in here, and then in additional context, we'll just add the code like this. We'll hit search, see what it gives us. We'll say, and it looks like find was able to find the answer. The error message indicates the function store in the add5 storage contract is missing the override specifier, which is required because it overrides a virtual function from the simple storage contract. Thanks. I'll explain what find is giving us in just a minute. It's right. We need to tell Solidity that it needs to override the store function in simple storage. We want to be very explicit and say, hey, do this store function and not what's in simple storage.sol. So let's go ahead and add that keyword override. Now though, if we just add that keyword, we go ahead and try to compile, we still get an error, trying to override a non-virtual function. Did you forget to add virtual? In order for a function to be overrideable, you need to add this virtual keyword in the base class or the parent class. So in simple storage, we need to add virtual to store. This virtual keyword means that this function is overrideable. Any function that doesn't have this keyword, you can't override. Now our store function is overrideable, and we've specified that we are indeed going to override the store function. Now if we go ahead and compile, we'll see everything compiles successfully. All right, great. So now let's just add the functionality to store. Remember, since add5 storage inherits everything from simple storage, this means that we even have access to my favorite number. So what we can do is we can say my favorite number equals underscore new number plus 5. We'll compile this, and now let's try it out. We're on Remix VM. We want to make sure we're with add5 storage. We'll delete the other ones. We'll deploy, scroll down, hit the drop down. Retrieve currently returns 0. Now if we store 2, we'll pull up the terminal to make sure we're actually sending transactions. We'll hit store. And now if we hit retrieve, we see we indeed get 7 back because 2 plus 5 is 7. We add 5, we hit store, retrieve now returns 10. So this is how we do inheritance and override functions. And that's it for this section. You've learned a ton of incredibly powerful features in Solidity. So let's do a quick recap of what we learned in this section. We learned that with the new keyword, we can actually deploy contracts from other contracts. We learned that we can actually import other contracts, which is essentially the same as copy pasting the code into this file. We also learned this thing called named imports, which is going to make you look even better than most of the Solidity devs out there. We learned that we can interact with other contracts so long as we have the address and the ABI. The simple storage type automatically comes with the address and the ABI, so we can just access it like this. We didn't learn too much about the ABI, but we'll learn more about it later. We learned that if we want to make a child contract and inherit the functionality of some other contract, we can just import that contract and then use the is keyword in the contract declaration. To override a function, we need the override keyword, and we need the base class or the parent class to have the virtual keyword on the function you want to override. And that is the end of this lesson. So be sure to give yourself a huge pat on the back. Take a break. Breaks are good for your brain. Go for a walk, grab a coffee, get some ice cream. Go tell your friends, go post on Twitter. You're getting more and more advanced with Solidity very quickly, so be sure to celebrate the little wins to keep being excited and keep that curiosity. Congratulations, you've completed this lesson.